My name is Ali Aktar, and this is Irfan Ansari. We have been working in the DevOps and cloud space for a while now, and we thought we'd combine forces and set up an organization to offer cloud and DevOps expertise, agile expertise, and there's about 5 or 6 of us in the organization. And this demo is basically trying to show how in Google Compute you can bring up some fundamental services that you can offer your organization for them to consume, and how you would do that in a really automated way using Hashistack tool sets. Can we have some hands from the audience who's used Terraform? Awesome. What about Console, Vault, Nomad? Nomad, anyone? Okay. So we're big fans of Hashistack. We've used these tool sets for lots of organizations. Wherever we've gone, we've kind of promoted that way of working because we found a lot of benefit in using uniform tool sets to orchestrate and automate different services, standardization, naming conventions, all these sort of good things that industry experts will tell you about. And my particular expertise is around kind of Kubernetes area, containerization, automation, and cloud automation for GCP, Azure, and AWS. Irfan?
I've been a developer for a long time. Actually, I've done Java development, Groovy, and Scala, and then decided to move on into Ops. Well, DevOps. I am more Dev than Ops, but I am DevOps. I see actually infrastructure as a code, and that's true. I try to utilize whatever I've learned in my development time, all those good practices, like even though we say TDD, but we do write some tests for our infrastructure as well.
Okay. Table of contents. So we've done the intros. Hashistack, what is it and why? We'll cover that off in really quickly. Fundamental services and that you should offer your organization, in any organization that you work in, what the services are. What tool from Hashistack offer these services? Some use cases that can be theorized and added to Jenkins pipeline, or whatever CI tool of choice. Some links and some Q&A at the end. I classed Hashistack and all the different services as an ecosystem. Kubernetes has an ecosystem, but I find Kubernetes is a very complex beast, and that's why you need lots of engineers to look after Kubernetes. Hashistack, we're a big fan of Hashistack because it's not that complex, single services, but put it all together, single binaries, put it all together, and it's a very powerful offering that you can use in any cloud environment, agnostic of, or even in the data center if you want to. And the other thing is it's actually founded and developed and practiced with DevOps principles in mind. Some of the services you can look at, you've got DNS, service discovery, key value store, security as a service, encryption at rest and in transit. You've got compliance, blue-green deployments. You've got TDD, BDD stuff that you need to look at. Clustering, container scheduler, microservice, repository manager. All these different services that any organization requires. We're going to show how you bring all that up in a really nice way and then destroy it as well at the end, hopefully. Some of the tool sets that offer these services. So you got Nomad. You can do blue-green deployments with clustering, Nomad, container scheduler. Console does service discovery, key value store, DNS as well. Load balancing, we'll use cloud provider, GCP-based load balancing. CI/CD, Jenkins, we brought up Jenkins, but we couldn't finish the work, so you'll have to give us some slack. GitHub integration, CIS compliance, you can use Chef. Vault is for your security and your key and your variable management and stuff like that. Nexus and Artifactory you can use from the repository manager. And a lot of these are open source, but paid for versions are available. Use cases, so a typical use case, you have some code in GitHub, how you will see that code through a particular pipeline into utilizing kind of repository manager, Vault, and then Nomad, which is basically the where you deploy a container or no non-container application, jars, wars, RPMs, short-lived jobs, cron jobs. And then we have backend service discovery as well. We're using Fabio that then automatically is discovered by the load balancer, and reverse proxy entries are also done automatically as well. We try and show that time permitting. The other use case is obviously the jars and the war files, how you deploy that within the same kind of pipeline. That's another use case that you can potentially look at. And then obviously the links and stuff that we will share the slides, and also we'll make the code that we've used available in our GitHub repo so everybody can play with it. Okay, now for the demo. Right, so we will show in Google, ignore my private emails there. Let's see, so here we will show that we've got a clean environment, that there's nothing running. Hopefully the instances should show up. Okay, so there's no instances, there's no instance groups, there's no templates. You'll see that there's no firewall rules either. Firewall rules, that's the app engine. VPC network, that's the default one. So the firewall rules there are all default, the routes are all default. You'd see the load balancer, there shouldn't be any load balancers there either. Okay, so what we're looking to do is basically bring...
Can you make that big, please?
Yep, the screen you mean?
Yeah.
Okay, okay. So what we're going to do is bring up a console cluster, a Nomad cluster, a Vault cluster, and we'll also bring up a Jenkins instance. We'll provision all the networking components, all the routing, the firewall rules, all the tagging, naming conventions around tagging. We'll bring up the entire lot in one go using Terraform. All of that is modularized, so you can use different modules selectively, whichever one you want to use. And yeah, we'll make that available in GitHub. So to get going, we do Terraform plan. Yep, I'll make that bigger, yep. Good suggestion there, okay. Sorry? A little bit down, that's too big.
The font.
I'll just drag the, you mean the font? Right, okay.
Can you control plus, command plus maybe?
Is that better? Is that better? Yeah? Yeah, done that. Is that big enough? How about now? Yeah? Right, okay, so what this basically gives us is a blueprint of almost like a dry run of everything that you've actually defined in your infrastructure as code, what your network looks like, what your ports look like, what your computes look like, what your subnet looks like, and it describes it in detail before you actually do anything. So it's a dry run. What you can essentially do is when you do the plan, you can also version control it with a crude method like this. So you could do plan, and then it will give you date stamp and by seconds or whatever, and it will give you an output. So you can basically version control that, put it into your source control and version it so that you know what changes you're making from one implementation to another implementation.
Just to add to that one, actually, you can configure your Terraform to use backend services. In fact, you can put all those
console as well.
Yeah, either in the console or maybe in a bucket somewhere.
S3 bucket somewhere. Yeah.
So yeah, it's a lot of capability, and I would like to add a little bit more about Terraform. That it's the same kind of language you can use for different clouds as well. Even
Azure, AWS, Google. Yeah.
There are tons of cloud providers who actually support Terraform. Terraform works very closely with Google and AWS and Azure, like major.
And you can break out into scripting as well. So if you've got custom Azure, for example, might not be mature in providing everything that Terraform can manage. So you can break out into PowerShell and then go back into Terraform. So you've got quite a bit of flexibility there. So we'll implement this, and then we'll see the services come up, and we'll try and log in as well at the same time and show some UIs, because everybody likes pretty pictures. So let's see if this will work. It's not tested, by the way, so hopefully the demo gods are in our favor today.
And being these all things actually in code, you can put into Jenkins pipeline, as Ali mentioned. And this one is interactive.
Or GitLab CI, as some of us like more GitLab CI than Jenkins, right?
So yeah, the way Ali actually started this one is interactive. So it's going to ask that, do you want to apply all these changes into your infrastructure? And if you're running in Jenkins CI or any CI actually tool, you can pass a command line argument which will not ask any interactive questions.
Yep. So it's creating all the firewall rules, it's creating all the tags, is then obviously allowing, using tagging, it's allowing one group of computers to access another group of computers. The clusters are being configured in the same way, so we don't have to like kind of go in and manually add security groups and so on as far as AWS is concerned, or firewall rules from one cluster to another. This is going to be done for us. It's also creating the load balancer right now. And the load balancer will then use Fabio's configuration to basically offer the services, so the backend services also configure that. So hopefully we should have load balancer there. And we should also have some computes.
Yes, I just said that I see code, then I see test as well. There is actually, there are a few guys, they have written something called Kitchen Terraform.
You can use that for TDD. And they
have some example for AWS.
We're not going to demo that, we have no time.
Of course.
So, but yeah, we've used Kitchen Terraform for testing as well, our code sets. Okay, so if I log into one of the console cluster, I should be able to see all the services that we brought up. All the services that were brought up also monitored as well. So we'll bring this up, log in to that. Hopefully that works. So I've just set up a port forwarding. We'll go into localhost, and we should see, fingers crossed.
Is port okay?
Yeah, should be. I've logged in. It may be too fast, and the computes haven't come up yet. Permanently added, already in use. Right, okay, that's why. My port forwarding is already in use. So let me just close some of these windows. Oh, that's why, okay. That one was already connected.
Cool. I think you're okay.
86678 Should have stopped. Okay, good. So let's try that again. Hey. Okay, so
Big.
yeah, let me make that bigger. Okay, so Vault cluster, the other nodes, the Vault cluster comes out sealed, so you've got to unseal it to use it. You guys are probably already experts in that. So we've got services like console, Nomad, Nomad client, and stuff like that being monitored already. And any kind of containers or services that you deploy, we're going to try and demo that as well. So we'll create a demo job and we'll deploy it, and we should see those services automatically monitored by console. Console is very lightweight. It's one single binary that you deploy into your nodes, and then you can register services, and it would do discovery as well. So let's try and get one of these sample jobs. Let's see, where are we? Nomad jobs. Let's get Fabio in there. Deployed. Nomad run, wasn't it, Fabio? So if we have a look at this, can everybody see that, or is it too small? How about now? So we see that Fabio is going to be coming up on port. The UI will come up on port 9998. And we should see, hopefully, the services also.
Start properly.
Has it? Nomad status. Yeah, it's running. http.nomad. Let's bring up another service while we're there. Example http. So that is EUS1B. Is that the one that we deployed it into, just to make sure? Yeah. Right, let's run that job. Nomad run HTTP service. Right, so Fabio and example have also just come up now. Took a bit of time for I think Sainsbury's internet connection was pretty slow today. So yeah, we can see that the services of I haven't had to do anything further to get the service, registered, monitored, or anything. I've deployed the service with my Nomad file, and I described the service. I put a health check endpoint, and the other magic that's happened here is that you'll see Fabio, and I'll try and log on to Fabio now and show you that the service, the example web service, has also come up within Fabio. So let me try and find out which node Fabio is running in. So I think it's this one here. Oops. So 9998, here we go. Let's do that. Let's see.
We have used actually console as a data store as well. Mainly the config store for the application. So whenever we develop any application, or our development team actually develop any application, we encourage them to not keep any configuration in the application and then keep them outside. And that's where this console works very well.
So who's used Fabio before? Anyone? Okay, so we know that it has a very close integration with console. And any services that's running within console, Fabric, and Discover, you can then configure your load balancers to hit a given endpoint, and then not worry about container addresses and ports like that. It kind of takes care of it for you. So yeah, that's the... Anything else to add? That's the end of the demo, right? Should we destroy it as a proof that we can just cleanly get rid of everything? And then we'll take some Q&A. Anything else to cover on Terraform? You're an absolute guru in Terraform now.
Yeah, Terraform.
Any tips?
Well, Terraform is evolving. Obviously, they are working with cloud providers, and cloud providers are adding more features every day. And then Terraform has to catch up. If you're working in the native cloud providers tools to build your infrastructure, then you'll be ahead. But if you're waiting for Terraform, then it may take a little while. And I don't work for Terraform.
Well, HashiCorp.
Yeah, HashiCorp, yeah.
So we're just going to get rid of it, clean it up. It will destroy everything. And that's end of the demo.